Hello everyone, I'm Disha Chakraborty, Science Faculty with Zeil classes. I'm a postgraduate BEd and UGC NET qualified. I strive to make chemistry comprehensible and fun. Today we are going to discuss about chemical reactions and their types. Let us first understand what a chemical reaction is. A chemical reaction is a chemical change where two or more substances undergo a permanent reaction, a permanent chemical change to form two or more new substances. A chemical reaction always has two parts, the reactant part and the product part. The reactant part is always kept at the left side of the reaction and the product part at the right side of the reaction. Let us take an example to understand how we write and represent chemical reactions. Let us consider the formation of water from hydrogen and oxygen. We will write the equation like this. And we balanced it. Now, hydrogen and oxygen are written on the left-hand side. These two are the reactants. And water, which has formed after the chemical combination of hydrogen and oxygen, is the product which has been written on the right-hand side. We can say that reactants are the substances that are taking part in the reaction, and products are the substances that are formed after the completion of the reaction. Chemical reactions are of four major types. The first type is known as a synthesis or combination reaction. The second type is a decomposition reaction. The third type is a displacement reaction. And the fourth type is a double displacement or double decomposition reaction. Now we will be discussing each one in detail. The first type of reaction that we are going to discuss are chemical combinations or synthesis reactions. From the name itself, we can understand that two or more substances will combine over here to synthesize or form one or two more new products. Skeletally, this equation is represented as A plus B gives us AB. To take an example with elements, we can consider the formation of water again, where hydrogen and oxygen, which are completely new substances, forms water, a substance which is very different from hydrogen or oxygen. So this type of reactions are known as combination or synthesis reactions. The second type of reaction that we are going to discuss is decomposition. This is the very opposite of synthesis or combination. Here, a substance breaks down into two or more new products. Decomposition can basically translate into breaking down. Decomposition reactions can be of two types: thermal decomposition and electrical decomposition. Thermal decomposition are decomposition reaction that occurs with the supply of heat. The word therm means heat, so thermal decomposition are reactions that occur with the absorption of heat. An example for this reaction is the decomposition of calcium carbonate. CaCO3 on application of heat breaks down into calcium oxide and carbon dioxide. An example of electrical decomposition is the splitting of water into hydrogen and oxygen. Electrical decomposition reaction occurs with the supply of electricity. When electricity is passed over acidified water, it splits into hydrogen and oxygen. As water is acidified because pure water cannot conduct electricity. A few drops of acid is given to water to make it a conducting solution. Skeletally, this reaction is represented as follows. A compound AB undergoes decomposition reaction to form its constituent elements A and B separately. The next type of reaction that we are going to discuss about are known as displacement reaction. Before learning about displacement reaction, we have to know the metal activity series. What is the metal activity series? Metal activity series states the reactivity of metals according to their decreasing order of reactivity. A very easy way to remember the metal activity series is to remember a poem. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. So, the metal activity series goes as follows. This is the decreasing order of the metal activity series. This means that potassium is more reactive than sodium, sodium is more reactive than barium, and so on. As we move down the series, the reactivity of the metals decreases. Metal reactivity series is important in learning displacement reactions because only metals higher in the reactivity series can displace metals in the lower in the reactivity series. So in a reaction, sodium can displace calcium, but zinc can never displace aluminium. Skeletally, this reaction can be represented as follows. Where A is displacing a metal lower in the reactivity series, which is B, and combining with C. A real life example of this type of equation can be sodium, which is very higher in the reactivity series, can displace hydrogen from its combination with hydrogen chloride and combine with the chlorine to form sodium chloride. The final type of reaction that we are going to discuss today are double displacement or double decomposition reactions. Again, these reactions can be classified into two types: precipitation reactions and neutralization reaction. Precipitation reactions occurs with the formation of a precipitate, and neutralization reactions are reactions that occur between an acid and a salt. Skeletally, this reaction can be represented as the displacement occur twice, so they are known as double decomposition or double displacement reactions. AB can be represented as A plus B minus, and CD can be represented as C plus D minus. The ion A combines with C and the ion B combines with D. The final type of reaction that we are going to discuss are double decomposition reactions. These are of two types: precipitation reaction and neutralization reaction. Precipitation reaction is followed by the formation of the precipitate, and neutralization reaction occurs as a reaction between an acid and a base to form salt and water after their neutralization. Skeletally, this equation can be represented as AB can be written as A plus B minus, and CD can be represented as C plus and D minus. The positive ion combines with the negative ion on this side, and the negative ion and the positive ion combines like this, and hence they form AD plus BC. A real life example of this equation can be given as a neutralization reaction will always occur with for an acid and a base. Let us take a base and an acid. This leads to the formation of salt and water. So this was a brief class on types of reactions. I hope all of you have understood what the basic type of reactions include. Thank you.